Interfaces are one of the most misunderstood features in Java, partly because a lot of people don't really know the real purpose of interfaces, and also because the meaning of interfaces have changed since Java 8. So I'm going to walk you through the original and real purpose of interfaces, and then we'll look at how this has changed over the past few years. We use interfaces to build loosely coupled, extensible, and testable applications. What does this mean? Well, earlier in the course, we talked about coupling, which is the level of dependency between two software entities like classes. So if class A uses class B, we say A is dependent or coupled to B. Now, if we change B, we might have to change the code in A and every other class that depends on A. Even if we don't have any breaking changes in the code, just because B is changed, it has to be recompiled, and that means every other class that depends on B and their dependencies should also be recompiled and redeployed. Now, this is not an issue in a small application with a few classes, but in a large, complex application with hundreds or thousands of classes, we don't want one simple change to cause a lot of cascading, breaking changes in several places. We don't want to change one line and then wait several seconds for hundreds of classes to get recompiled. To prevent these, we should try to keep the coupling or relationship between our classes as loose as possible. Let me give you an analogy. Think of your car. If there is an internal problem in the engine, you only want to replace that part, right? You don't want to replace the tires. That makes no sense. This is loose coupling in action. Now, how can we reduce the coupling between these two classes? Well, earlier we talked about the abstraction principle of object-oriented programming, which says we should hide the implementation details of our classes and only expose what is necessary. So by hiding certain members using the private keyword, class A will know less about class B, and this will loosen the relationship between these two classes. But that's not enough. And that's where interfaces come to the rescue. With an interface, we can completely decouple A from B, so it knows absolutely nothing about it, like it doesn't even exist. If we change B, A is not going to be affected. Now, what is an interface really? An interface is a type similar to a class, but it only includes method declarations, no implementation. It has no code. It only defines the capabilities that a class should have. Let me give you an analogy. Imagine you have a restaurant. You need a chef. You don't care who the chef is as long as they have certain capabilities. This is an example of loose coupling. If something happens to your chef or he or she decides not to come to work, you can replace them with someone else with the same capabilities, right? Now, in contrast, what if the chef had to be John? Then your restaurant is tightly coupled or strongly dependent on John. If anything happens to John, you're in trouble. So back to our classes. We don't want class A to be directly dependent or coupled to class B. Because with this, if we change B, A might be affected. So to minimize the impact of changes, we put an interface in between these two classes and decouple them. Now, if we change the code in B, A will not be affected because it knows nothing about B. This is what we call programming against interfaces. So we code our classes to work with interfaces, not concrete implementations. And with this, we can build applications that are loosely coupled and extensible. Tomorrow, we can easily replace B with another class that implements this interface. This makes it relatively easy to extend our applications. For example, let's say we use B to perform face recognition. Tomorrow, we can replace B with another class like C that does a better job at face recognition. It's faster and more accurate. This will not affect the rest of our application. We simply replace one class with another one. As long as both of these classes follow our contract or interface, everything will continue to work. As another analogy, think of your phone. Your phone has an input for the charger. This input defines an interface. You can use any charger that follows this interface or contract. As long as the size fits, you can use it to charge your phone. If one charger is slow or becomes faulty, you can replace it with another charger. So, an interface gives the idea of what should be done, and classes that implement that interface determine how it's done. Anywhere we need to have the flexibility to swap how something is done, we can use an interface to make our design loosely coupled and extensible. Examples are data compression, encryption, sorting, and searching, to name a few. Today, you may be using one searching algorithm. Tomorrow, you may want to use a different algorithm that is faster and more accurate. You define an interface that says you need to be able to search data. Then you create different classes that implement that interface or contract. Each class will use a different algorithm for searching data. As another example, let's say you're building an application for calculating taxes. Each year, tax rules might change, but every year, you need to be able to calculate the tax. So your interface specifies what should be done, which is calculating the tax, and different classes will provide different ways for calculating the tax. Each year, you can swap one implementation with another. So interfaces are about what's and classes are about how's. So with interfaces, we can build applications that are loosely coupled and extensible. We can easily extend or replace various parts with minimal or zero impact on our application. We can also independently test these parts and make sure they're working. This is what we call unit testing, which is a topic for a completely different course. So this is the real purpose of using interfaces. Over the next few videos, we're going to see these concepts in code.